Hello, I'm Who Are We, and today we're going to be talking about Ice Age fishing in Beringia. Beringia includes areas such as the Chukchi Sea, the Bering Sea, the Bering Strait, Chukchi, and the Kamchatka peninsulas in Russia, as well as Alaska in the United States and the Yukon Territory. Of course, I am not Russian, so sorry for those pronunciations, or I'm not Aboriginal either. I'm not really sure which ones they are, but we're talking about a study here, which I found very interesting. So, this is a landmark study by Potter, Halfman, McKinney, Ruther, and a dedicated team of collaborators titled Freshwater and Anadromous Fishing in the Ice Age, Beringia. This paper, published in Science Advances, offers a sophisticated, multidisciplinary reappraisal of early human economies in central Alaska, fundamentally challenging previous dichotomies of Paleo-Indian subsistence models. The research imperative addressing the taphonic and theoretical gaps. For decades, the prevailing narrative concerning early lifeways in the early Pleistocene and early Holocene, roughly 14,000 to 7,000 calendar years before present calendar year BP, has been polarized. It has been framed either as megafaunal specialization, high mobility hunting of large terrestrial game, or broad spectrum foraging. Conspicuously, the role of fish has been largely regulated to a minor or absent element in this discussion. The reason for this historical oversight are twofold. Taphonic bias. Fish remains are tiny, fragile, and susceptible to poor preservation and low recovery rates in zooarchaeological assemblages. This makes distinguishing between natural accumulations from fish and minks and cultural accumulations by humans particularly difficult at sites like caves or water margins. And theoretical bias. In inferior settings, a focus on megafauna has often overshadowed the potential economic importance of smaller resources. The Beringian advantage. This study sidesteps these challenges by focusing on Beringia, the ice-free refugium that hosted a variety of fish taxia during the last glacial period. Crucially, the Middle Tanana Basin in interior Alaska, which is the locus of this research, features open-air losses deposits where excellent organic preservation occurs. The Tanana Basin also holds the densest concentration of late Pleistocene sites in America. This environment provided a unique window to observe early Paleo-Indian fishing adaptations in a primary anthropogenic context. The authors defined their research goal as addressing two primary problem areas: economic adaptations relating to the peopling of the Americas, and economic change through time in response to climatic oscillations during the Pleistocene-Holocene transition. Methodology: integration of zooarchaeology and biomolecular science. The researchers conducted a comprehensive review of 7,000-year-old or older sites in the Tanana, Kuskokwim, Susitna, and Copper River basins, ultimately yielding 10 archaeological components, 8 of which had fauna available for study. Zooarchaeological analysis. A total of 1,110 fish specimens were recovered and analyzed, with 627 or 56% identified to a lower taxonomic level. Taxonomic identification. Identified taxa included Anadromous Orchioclypus SPP, salmon, and 3 freshwater taxa, Lotta, burbot, subfamily Corganine, whitefish, and Esox lucius, Northern Pike. Notably, taxa commonly used today, such as grayling, Thymus articulus, char, Slavilinus spp, and longnose sucker. Catsumus catostomus are not identified. Body part representation. The vast majority of specimens, 84%, were vertebrae, with 15% cranial elements. The pattern for the major assemblages, burbot at Med C3A and salmon at Upward Sun River C3, were highly similar in fragmentation and body part representation. The similarity suggests similar processing methods were used for both species, which is a key contrast with later ethnographic patterns where salmon processing was typically intensive. Taphonomy. All sites were situated on a positive geomorphic landforms, bluffs and terraces, not river and lake shorelines, where natural fish predators typically operate, reinforcing the anthropogenic origin of the assemblages. Furthermore, the fish remains were directly associated with cultural features like hearse. Biomolecular analysis. To confirm identification and reconstruct diet, two primary biomolecular techniques were applied. Ancient DNA, aDNA analysis. DNA was recovered from 19 specimens, successfully identifying 58% of the species level. This confirmed the presence of burbot, or lata, and chum salmon, Oncornius ceta. The aDNA results validated the morphological identifications. Stable isotope analysis. This analysis confirmed the distinct ecological niches of the recovered taxa. The chum salmon exhibited a relatively high delta 13C and delta 15N values, a chemical signature demonstrating feeding in marine environment, hydrodynamics. Conversely, burbot and whitefish showed more negative delta 13C values consistent with freshwater ecology. The high delta 15N values of freshwater fish also reflected their high trophic positions as predators. Chronology and environment context in early fishing. The research established key chronological benchmarks for early fish exploitation. Earliest freshwater fishing. By at least 13,000 calendar year BP, primary burbot documented at Mead C2B, roughly 12,950 calendar year BP, and Swan Point CZ3B, roughly 12,600 calendar year BP. And the earliest Anadromous fishing by salmon was at least 11,800 calendar year BP. The Younger Dryas nexus. Crucially, the temporal distribution of fish remains is far from continuous. All identified occurrences but one fall within the Younger Dryas YD chromosome, roughly 12,900 to 11,650 calendar year BP. The Younger Dryas was a cold, dry stadial that interrupted the warmer boiling alderoid BA interstadial and preceded the warmer early Holocene. Key findings relating to this climatic link. Absence of BA. Earlier boiling alderoid components show no evidence of fishing. Near absence in early Holocene. Fishing largely ceased after 11,500 calendar year BP, with a single exception at Hollenbach's Hill from 8,800 to 7,890 calendar year BP. Fish as a Younger Dryas strategy. Fish-bearing components comprise a significant 69% of occupations during the Younger Dryas in this region, compared to 30% of all occupations earlier than 7,000 calendar year BP. This strongly suggests that fishing was a common economic strategy, specifically during this cold, dry period. This pattern indicates a direct correlation. Human fish exploitation was temporarily limited, coinciding precisely with the Younger Dryas stadial and contrasting sharply with the warmer, wetter conditions of the surrounding periods. Discussion: a model of stress-induced diet widening. The research leads to a powerful interpretation regarding human response to environmental change. The climatic driver hypothesis. The authors proposed that fishing was a response to changing environmental factors, possibly reflections in higher ranked resources, notably large terrestrial mammals, as the climate worsened during the Younger Dryas. This aligns with other regional faunal research suggesting a widening of diet breadth at the onset of the Younger Dryas. The environment would not have influenced the fish themselves. During the more arid Younger Dryas, the relative abundance of burbot, a deep water, often lake-dwelling fish, compared to whitefish often found in the more riverine habitats, may be explained by the relative suitability of streams versus lakes at the time. Nature of the late Pleistocene fishing. Pleistocene. A crucial aspect of this study is the characterization of the late Pleistocene fishing strategy, which contrasts sharply with later ethnographic practices. A feature was the primary economic role of the later Pleistocene Younger Dryas fishing by Potter, which is an element of broad-spectrum foraging sites dominated by mammal resources. It was denoted by intensive communal fishing and storage, where fish are critical staples, and processing and storage, which were low-level consumption. No evidence of intensive processing or storage, such as cache pits. There was bulk harvesting, processing, drying, and storage for winter and early spring. The seasonal focus found situational exploitation and spring burbot, med C3A, and summer and fall salmon in the Younger Dryas period, whereas recent fishing has found intense seasonal exploitation, peak harvest in summer, June to August. And when we talk about technology, inferred in the Younger Dryas, it was likely small-scale net technologies, for example, dip nets, set, and gill nets, whereas recent technology is predominantly nets and traps, often with weirs, rarely hook and line, or under the ice for salmon and whitefish. Burbot and pike are caught in nets and traps and hooks and line, often under ice. Defining at upwards Sun River C3 provide direct evidence against overwinter catching of salmon. A paleo diet analysis of infant showed a measurable increase in salmon diet between spring and summer, a pattern inconsistent with consuming cache salmon year-round. Lifeways and mobility. The shift towards fish during the Younger Dryas represents an economic adjustment. The earlier populations, before 13,000 calendar year BP, exhibited a high residential mobility focus on megafaunal hunting, a forager strategy, but the Younger Dryas populations expanded their diet, likely in response to declining megafauna. The widening of the diet implies a move towards collector-like strategy, sensu Binford, and this strategy involves reduced mobility, local knowledge of seasonal resource peaks, a mapping on strategy where residential base camps like Upward Sun River C3 and Met C3 were situated to exploit a broad spectrum of local resources, with fish serving as an important secondary factor in site location. Fish likely served as a buffer food during expected periods of resource stress, such as late winter and early spring. To conclude, the study by Potter and colleagues provides an unequivocal evidence of the earliest secure anthropogenic use of freshwater and Anadromous fish in North America, dating back to 13,000 and 11,800 years ago, respectively. This research represents a model where economic change was not unidirectional, but was instead a complex response to severe abrupt climatic fluctuation. The integration of multiple fish species was a vital stress-induced adaptation during the Younger Dryas. This temporary but important dietary shift during the Younger Dryas established a successful pattern of exploiting predictable aquatic resources, laying the foundation for the far more intensive and pivotal role fish, particularly salmon, would play in Alaskan native lifeways during the later Holocene. I want to thank you all for watching. If you made it this far, I hope that you enjoyed. Please feel free to leave any comments and likes in the description. If you want to know more about fishing, there's a book out now called A Systematic Approach to Northern Pike Fishing, a data-driven guide to pike ecology, equipment engineering, and tactical fishing strategy that reviews the ecology and various other things about angling for pike. The link will be in the description. I hope you enjoy, and thanks for watching.